Greetings and welcome to Tryhard Studio, and to this, our 5th devlog, where we finally, after several failed attempts, introduce our dynamic system for obstacle navigation. All of this coming up next. We had previously commented that being the exploration and investigation of our scenarios, what presents the decisions and guides the narrative of our game, creating that ideal obstacle navigation system was one of our biggest priorities and concerns. Intuitive, so that the player manages to master it quickly. Robust, to be able to adapt to diverse and specific circumstances, but flexible enough to be able to introduce new dynamics and behaviors if necessary. This week, I finally dedicated myself entirely to solving this important mechanic. And despite finding various dead ends and having to erase several days of progress, finally we got to the system that offers what we need. Previously, we had implemented an extremely primitive and laborious system, in which using box colliders with different locations within our character to identify the type of obstacles and their heights. These colliders triggered events that led our state machine to implement the corresponding behavior and animation. After this, the character's mesh began to clear the obstacle guided by the animation, leaving our inactive character controller behind. And later, at the moment of reaching the final frame, teleport the character controller to the ending position of the animation to finally reactivate the player's control once again. This system came with all kinds of drawbacks. To begin with, the available maneuvers were extremely limited. You needed to create an independent state for each obstacle, or create a single overcomplicated state to indicate the corresponding animations and their destinations, and all of this without even taking into account that each maneuver would only work with a specific height, so that you will have to make sure that all of your obstacles had a precise separation so that the movement looks somewhat correct. This in addition to saturating every one of the dozens of obstacles we need with box colliders, and of course, since we're teleporting our character controller, we can use fades between animations, or we would see the mesh being pulled from its starting point, so our animations were jumping all the time. In addition to that, all of our other behaviors, such as enemy targeting, combat and damage detection, were all left behind while all of this happened, so you could not use obstacles to evade enemies. That and many other problems that will surely pop up later. Needless to say, this is not the most recommended approach. It may have been an acceptable temporary solution, but at this point it's no longer fulfilling this purpose. According to my research of the last few days, the best alternative is to use root motion and target matching. That, to put it in a very simple way, works as follows. Root motion allows us to use the position of our character within its animation to move the controller. This is possible when you assign a Unity Bone avatar to each of your animations, so that the engine knows the position, rotation and name of all the bones at each frame. So that now we can alter their values, such as the height of a jump, for example. This allows us to use target matching to modify the animation to suit different obstacles and to take our character controller along with it. Well, bless the day, this solves all of our problems. And then I finished and launched the game that was a success and everyone applauded, but no. Rather, I spent 3 days re-downloading all of the animations from Mixamo, because as I had completely unpacked them to edit frames and values, none of them were of any use to us now. I had to configure the animator of our character again from scratch, and add the animation names again to our code, because of course I changed the default names that didn't make much sense to me at the start, only to find out later that many of our previous codes with which I was satisfied no longer work with root motion. Neither the momentum in the jump nor the ground detection, and for some reason I could double jump in the air. No, I did not record these errors at the time, I was very stressed, and yes, I do regret it because it looked quite funny. It was at this moment that I made a difficult decision. On one hand, I could erase the progress of the week, and go back to our primitive code and animations, and regret this decision for the rest of the project. Or I could spend the next few weeks editing all the previous movement codes, which were working properly, knowing that target matching doesn't seem to be reliable all the time, and knowing that since I do not master this new process at all, will surely means finding new errors at every turn, and surely end up regretting this decision for the rest of the project. Or as a third option, which was the one we took, taking advantage of the fact that I have finally reached the point in my programming career where I think I understand what I'm doing, I could dismember the root motion system, take all the useful parts and shoehorn them into a simpler, more rudimental system that mimics Unity target matching, in order to create a more reliable but less versatile system, and only regret this decision, occasionally, in specific scenarios that hopefully I can adjust into. In a very simple way, our new system works like this. A raycast that starts out above the general height of walkable steps can detect whether or not there is an obstacle in front of us. If so, another raycast that we offset forward of the first collision in the opposite direction of the normals of the obstacle is used to detect the height we want to reach. And at the moment the player jumps in front of the obstacle, our parkour state machine makes a loop between all the parkour actions that we now have as modular scriptable objects to see which of them correspond to the desired height. In this way, we can add as many actions and animations as we want. We cannot take control until the interaction is over, but we can be harmed if we are hit during the process, event that interrupts this state and returns us to the general free look movement. The vertical movement is a dynamic I-twin adjusted to the height detected, and the frontal movement, for now, is a fixed value, configured for each parkour action, and we can choose its magnitude and starting frame according to the selected animation. Both move the whole character, so it is possible to use it in combat with the expected results. I also want to take the opportunity to show off the last bark texture Ellie has created, and to announce that she's already working on the model of the main character, so if everything goes well, very soon we can forget about the generic mannequin we've used so far. And well, with this I conclude the progress report of the week. Even though our main obstacle navigation engine has already been resolved, I still need to add actions that allows us to jump over fences and other thinner obstacles, and finish refining our wall climbing logic, in which so far I've worked very little. I think I'll be putting in this our efforts of the following week, but once finished, our options for level design will expand enormously. Thank you very much for staying with us until the end of the video. If you're interested in our project, please consider subscribing or follow us on Twitch, where you can find us every Tuesday and Thursday, link in the description, or perhaps a like or comment, which are greatly appreciated. I am Mark from Tryhard Studio. See you again next week, and until then, just to wish you, as always, a lot of success in your projects. Later!